expressions and functions. For a square root, the number b is the square root of a if b squared equals a. For example, 3 is a square root of 9 because 3 squared equals 9. So we're just using the definition and putting in our specific numbers. Now, -3 is also a square root of 9 because -3 squared is 9. So b has two square roots, positive and negative. Cube root. The number b is a cube root of a if b cubed equals a. For example, 2 is a cube root of 8 because 2 cubed equals 8. Now, 8 is not going to have also a negative cube root because if we place -2 in parentheses and cubed it, we would have a -8, not a +8. So we only have positive and negatives when we have square roots. The only time we would have a negative cube root is if we were taking the cube root of a negative number. So what are the square roots of 9? 3 and -3. What is the cube root of 8? 2. Let's evaluate the square root of -25 if possible. Well, when we look at that, we see there are no numbers that I could multiply by themselves 2 times and get a negative number. Even if it were a negative number, a negative times a negative would be positive. For example, -5. -5 times -5 is a positive 25, so -5 is not a square root of -25. And of course 5 doesn't work either. 5 times 5 is 25, not -25. So for now we'll say that this is not possible, at least not as a real number. The expression square root of x squared. For every real number x, the square root of x squared is the absolute value of x. So when we take the square root of a number, it needs to be the absolute value of that number. In other words, they're asking us here for what is called the principal square root or the positive square root of a number when they already have the square root on it. If they had asked for the negative square root, they would have to put a negative in front of the radical symbol. So when I have something like the square root of 9, I know they're asking for the positive root. If I'm asked for the square root of 16, I'm going to give them the positive 4 because they're asking for the principal square root or the positive square root. Evaluate the expression by hand if possible. Variables represent any real number. Here we have the square root of -9, and that is 3. The square root of 0.36 is 0.6. If you would like, we can grab the calculator and put that in. I have a square root right here, second x squared button of 0.36, and I'm going to close my parenthesis here. Enter is 0.6. The square root of 16 over 25. In other words, what times itself would equal 16 over 25? And we would get a 4/5. 4/5 times 4/5 is 16/25. The cube root of 27. In other words, what number times itself 3 times would give us 27, and that number is 3. Cube root of negative 64. In other words, what number times itself 3 times will give us a negative 64. I know I'm going to have a negative here. I can put this into the calculator if I like. Now the cube root is going to be under the math button. In my calculator, it's button 4. So the cube root of negative 64, close parentheses, equals negative 4. Negative 4 times negative 4 is a positive 16, times another negative 4 is negative 64. Cube root of 8 over 27 is 2/3, because 2/3 times 2/3 times 2/3 would give me an 8 over 27. Negative cube root of x to the 9th. So here we have a negative, and the cube root of x to the 9th. What times itself 3 times would give me an x to the 9th? It'd be x cubed times x cubed times x cubed is x to the 9th, so I know it's a negative x cubed. Here, the cube root of 27x cubed. The cube root of 27 is 3, and the cube root of x cubed is x. 3x times 3x times 3x will give us 27x cubed. Now the notation nth root of a. The equation nth root of a equals b means that b to the n equals a, where n is a natural number called the index. Some people like to call it also a root. If n is odd, we are finding an odd root, and if n is even, we are finding an even root. If a is greater than 0, then the nth root of a is going to be a positive number. But if a is less than 0, if our radicand is less than 0, in other words, it's a negative number, and we'll have two cases. If n is odd, then the nth root of a will be a negative number. If n is even, then the nth root of a, it's not a real number. For example, if I'm taking the 4th root of negative 8, that will not be a real number. Evaluate the expression by hand if possible. Variables represent any real number. 4th root of 625. If you'd like, we can put this into the calculator. You'll notice under the math button we don't have a 4th root, but we do have an xth root. So what we can do is first, on that home screen, place our index number, and then math, and then option 5 for me is that xth root, and it puts the 4 in this little crook of the radical sign. So we're taking the 4th root of 625, and that gives me a 5. 5 times 5 is 25, times another 5 is 125, times another 5 is 625. The 4th root of negative 16. I'm being asked to take an even root of a negative number, and that's not possible. The square root of negative 4 squared. So if you'd like, we can do this using our order of operations. We're going to do what's inside that grouping symbol first. The square root is a grouping symbol. So negative 4 squared is positive 16. The square root of 16 is 4. We can also look at that rule on square root that said for any real number x, the square root of x squared is the absolute value of x. So here we have the square root of something squared is going to be the absolute value of that thing. So it's a 4. Here I have the square root of z to the 4th. What times itself would give us a z to the 4th? A z squared. 4th root of y to the 4th. Here I know I'm having an even root of y to the 4th, and it's going to be a y, but we're being asked for the principal square root. Remember, there's no negative in front here. So they want the positive square root, or since 4 is an even number, it's considered a square root. They're asking for the principal or positive root of this number. Now, if y has a negative value, then y would be negative here. We need to make sure that we have a positive number here. So we'll have to force it to be positive by placing the absolute values around that variable. Here, the 5th root of x to the 5th is x. Now, this is an odd root, so I don't have to worry about whether that result is positive or negative. Here, we just take the number as it is. If x is negative, then x will have a negative value here. If it's positive, then it will have a positive value. That does it for this section. Be sure and let me know if you have questions as you try your homework.